All right, get my screen pulled up here. 1 second, I apologize. There we go. I should be working now, I think. All right, well, my name is Justin Harrison. I want to just get directly into it here. My presentation is on the effects of food on the brain. So I obviously like to eat a lot, so that's kind of what came to mind. But just to get directly into it here, I think it's important to start with what the brain is made of. So for my research, I determined that it's made of lots of different things, but amino acids, proteins, micronutrients, and different types of fats. So again, I thought that was kind of an important note to start with, but just a little bit about some of the essential fats that our brain is made of. So omegas 3 and 6 are, some of those, and they're very important in a lot of different ways. But something I thought was really interesting was the fact that these fats are linked to linked to preventing degenerative brain conditions. So they come from our diets. A lot of times they're like nuts and seeds and fatty fish and stuff. They're like really high in these types of fats. So they're apparently crucial to cell membrane production. Something that, like I said, I thought was really interesting was about that, preventing degenerative brain conditions. I mean, I thought it was really crazy that, you always hear about healthy food and all, but really legitimately the type of food that you eat can have effect on how well your brain works over time even, and how quickly you're able to think, your mood and stuff. So it's kind of crazy. But a little bit about proteins and amino acids. So apparently these are the building blocks of building block nutrients of growth and development. So they contain the precursors to neurotransmitters, which is apparently like a chemical messenger that carries signals between neurons, as well as that these things can basically affect how we feel and behave, which I find that very interesting yet again. I thought that was really crazy. So just to kind of get into food and serotonin, that's kind of a little bit more of my focus was serotonin and the production of it. So basically this hormone is capable of affecting our mood, our appetite, sleep regulation, as well as it assists in food motility as well as bone metabolism. So kind of an interesting point to make, I think, is that the vast majority of serotonin in our bodies is created in our gut. So that kind of solidifies to me that the food that we eat can have a legitimate effect on our thought processes and our mood. Like I said, just the way we interact with people and stuff like that. So see the graph on the left kind of shows, after a meal, serotonin, there's like an uptick in the production of serotonin. So this is apparently created from tryptophan, which comes from the food that we ingest. So this kind of goes through a couple of different processes. It's acted on by a couple of different compounds, but eventually becomes serotonin. So another interesting thing that I thought, that I've kind of realized, I guess, is that our body's like machines. We kind of talk about the physics of the cells and all, but really our bodies in general are like machines. That they're capable of taking some, I don't know, some sort of compound and completely changing it into something totally different, something that's capable of, making our brains work a different way. So I thought that was really interesting. But a little bit about, to kind of get into the, more kind of quantifiable section of my presentation, which honestly was kind of difficult to find that sort of information, which I don't know. But basically, I'm going to speak a little bit about serotonin uptake velocity. So this, from my interpretation and research, is the velocity at which serotonin is incorporated into the body. So it's crazy, but this apparently can be estimated mathematically. So what I found was a paper specifically that talked about estimating serotonin in uptake in fruit flies. So the equations and all that I'm going to be talking about are from that. Yeah, so to get just into this portion of it here. So we're using, these equations kind of referring to these graphs here, estimating uh, KT and Vmax is what we're trying to do here, where KT is the kinetic constant and Vmax is the maximum uptake velocity. So if you look at the graph in the middle there, the decay portion of each peak was acted on by an exponential decay function. So that's why it kind of falls off the way that it does. So basically here, A is the serotonin concentration in time, and A max is the peak height of the curve. So basically to estimate the velocity, we use these equations that are shown here, where A max is, again, the peak height in nanomoles per liter, and K is the first order rate constant. From this equation, it was determined that Vmax was approximately 170 nanomoles per liter, and KT is approximately 350 nanomoles per liter. So basically, using the information that I found and kind of reading through it, it was determined that, the max rate of uptake would be achieved at concentrations higher than 4 micromoles per liter. So I guess what's interesting to me about that is that, something that is physically impossible to see, it's all done on just an unbelievably small scale. And yet it still applies to what I've learned. I thought that was kind of cool. So, I mean, that's the gist of my presentation. But with that said, I just basically wanted to say that I found it really interesting that we've reached the point in science that we're capable of even making this type of calculation. It's really unbelievable to me. Honestly, it's a little over my head. I think it takes a smart person such as yourself to get it, but it is really, really interesting. It's something I found really cool was seeing the similarities in the way that larger, like physical bodies, like machines and all, react in comparison to these like really small microscopic bodies. It's crazy to me that they have similarities, and we use a lot of the same equations to kind of characterize their movement. It's awesome to know that. I think that's really cool. So it kind of just solidifies that what I've learned and what I am continuing to learn academically is on the right track. I feel like that's the truth. I think that's really cool. But thank you for a good semester. I really enjoyed the class. I mean, I am not the great at participating, so I apologize that I wasn't the greatest there. Kind of a shy person, but I really can tell through the lectures just in general, as well as like that, especially the last lecture, that you have like a legitimate love for what you do, man, and that's really cool. It's like it's not common to see that anymore. I don't think. But I really appreciated your approach, and again, like I said, your legitimate desire and love for what you do really showed in the way you spoke and the way you taught. So, thank you. I really appreciate it. I hope you have the best of luck going forward. All right, thanks. Bye.